Got to give the people what they want. Give the people what they want. All right, cool. Did it. All right, it's Friday. I really don't feel like doing this video, but I'm gonna make it happen. Okay. Describe your functions and the rational function. So this first part is just gonna be about describing functions. All right. The main thing I want to talk about is how do you tell if a function is increasing or decreasing. Okay. So increasing versus decreasing. I can tell if a function is increasing or decreasing by watching its behaviors as you move to the right along the x-axis. All right, so pause that, write that down, draw these different pictures. For each of these, I actually want you to write if you think this is increasing or decreasing. You write it first. Cool, you did it. This one, as I'm moving to the right, this graph is decreasing. So this is decreasing. What's happening as I'm moving this direction, the line is going down, 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 down. Decreasing. This is a tricky one. This is both increasing and decreasing, right? As I'm moving along this way, I'm decreasing, 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 until this reflection point right here, and now I'm increasing, increasing, increasing. So from here to here is an increase. From here to here is decreasing. Then this one, I start here and I'm going across and going up, 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 up. This is increasing. So when you're doing those descriptions and they're asking you, oh, is it increasing or decreasing? That's how you look at it. It's basically saying, what does the output do? As the input x, as my x values increase, what happens to my outputs? Are they also increasing? Or as my x values increase, are my y values decreasing? That's what that is. First part, not a big thing. Oh, I dropped my pen. Not a big thing, but I wanted to make sure you have it. Boom, I'm gonna give you the second part. All right, so next we're gonna talk about this rational function. Why does it look like it actually looks, okay? So here's my rational function. It's when you have y equals 1 over x. And then I get this graph that looks really weird. It's like split in two different parts and it looks like that. First thing I want to remind you of is these things that are called asymptotes. So in this situation, right, I have an imaginary line that happens to be my y-axis right here. This will always approach this line, but it will never ever touch the y-axis. Like it will never touch and cross over. It will just keep edging closer and closer to the y-axis, this imaginary line right there. That line is called an asymptote. Same thing down here. This graph gets closer and closer and closer to the y-axis, gets closer, 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 but it will never touch the y-axis. The y-axis in this case is an asymptote, this word right here. Same with the x-axis. In this case, the x-axis is also an asymptote because this line is going to approach, get closer and closer and closer, but it's never going to touch it there. Same here, it's going to get closer. That's a terrible drawing of it. It's going to get closer, 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 but it's never ever going to touch it. That's why you see that it never crosses. And that should be a dead giveaway that there's an asymptote there when you see this arrow, but you don't actually see it ever go under there. That should kind of be a giveaway that there's probably an asymptote there. So the question is, why does this thing look like that? Well, at the y-axis, that's the 0 points. First of all, let's talk about my x values. The only number that I could never put here is 0. So x will never ever get to 0, right? Because 0 doesn't work. I could never have where the x value is 0, which would put me on the y-axis because that becomes undefined. So I can get super duper close to 0. I could get 0.00000000001, and that works. But as soon as I put 0, it doesn't work. So I see, right, my x values are getting bigger, 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 and now I'm getting, my x values are getting closer and closer and closer on the positive side to 0. But they're never going to touch. It keeps getting closer to that 0. Same thing on the negative sides. Again, we're just talking about the x values. So here's my x values, here's 5, here's 4, here's 3, here's 2, here's 1, negative, all those are negative, negative 1, negative 0.5, negative 0.2, negative point whatever. It's going to get closer and closer to 0, but it's never going to get there. That's why you get that asymptote at y equals 0, which is, at x equals 0, which is where the y-axis is. Since x can never equal 0, let's think about my outputs. Actually, scratch that. Forget that I said since x. But let's think about my outputs now. Okay? I could never get 0 for a y value because if I have 1 over a number, it's never going to be 0. If I have 1 over something, it's never going to be 0. It could be a really small number, it could be a really big number, but it's never going to be nothing. The only way that I can get an output of 0 is if I had 0 on top here, or if I could possibly get a 0 on top. But since I always have 1 in the denominator, there's no fraction I can write with 1 in the denominator and some number underneath it. There's no way for me to get 0 with this setup. So in the same way that x could never be 0, y could never be 0. And you see along the y-axis it's working in the same way. Like y can get to be, it can be really, 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 really small. My y values are small, but then it gets down here, and it's never going to actually touch 0. Same over here, as my y values get bigger, they get closer and closer and closer to 0, but then it hits a cutoff and it starts getting really close to y equaling 0, but it never ever touches it because there's no way if I have 1 over some number for me to mathematically get a 0. All right. It's not a lot to write today, not a lot of notes, just a couple of random pieces that we didn't really get to talk about too much in class. We wanted to make sure you had them though. I'm out. Have a good weekend. Hey, my bad, Chillis's class, for not posting your homework. Well, maybe you're happy about that, but then you probably got to do it later, so my bad.